Happy Thursday, everyone. It's energy test review time. Again, I apologize. I think most of you got the message, but the test is going to be on Monday, not on Friday as we originally had set it for. There is no distance learning on Friday, so you got a nice Easter weekend to study for your science test. Um, in regards to your projects, I've been really impressed. I've seen a lot of really great work coming in, so keep that up. If you have not submitted your energy presentations yet, please do that through Schoology. There should be you can just, again, make that link and share it with me that way. And we'll get you some feedback on that. I look forward to seeing what the rest of you come up with, those of you who have not turned yours in yet. All right, let's see. Oh, it looks like we got a question from Marianne today.
I wonder what's going to be on the test.
Well, Marianne, I'm glad that you asked because looking back at the start of this unit, of course, it's about energy. And we talked through about how energy is the ability for something to make a change. We talked about the relationship it has with work and how work and energy go hand in hand. And work is a transfer of energy. We learned a little more details about a couple types of energy. Kinetic energy and potential energy are going to be a couple really important ones for us moving forward. And kinetic energy, of course, the energy of motion and moving objects. And that's going to depend on the mass and velocity of the object. And we learned about potential energy. It could be either elastic potential energy, like wound up in a rubber band, or gravitational potential energy. And for gravitational potential energy, we also learned that we have to keep in mind some factors that determine it, namely the mass, the height, and the acceleration due to gravity, wherever that object happens to be. Oh, got another question. Brianna?
Will we have to do any problem solving questions?
Excellent question. We have learned a few formulas this unit, and so we will take a little time and get to show off how smart you are with these formulas. Yes, you will get to use your formulas on the test, so you don't have to have them memorized, but we'll just talk through it. We have a formula for work, which is, of course, force times distance. And you see also an important aspect is knowing the units of measurement that we're using for the different variables. Work is a form of energy, so it will be in joules. Force is in a unit called newtons, and we'll get into that a lot more in the coming weeks. And distance is going to be in meters, something that should be pretty familiar to with you. Kinetic energy is in joules. Mass, whenever we do mass, we'll do it in kilograms. Velocity or speed is going to be in meters per second. And then for gravitational potential energy, you see mass again, and gravity, or the acceleration due to gravity, is in a unit called meters per second squared. And here on Earth, that things fall to the ground at 9.8 meters per second squared. And then height again is going to be in meters. So if I had to do a problem solving question about work, it says if an object has a weight of 500 newtons and is carried for 4 meters, how much work is done? Well, the first thing we need to, of course, remember is that we want to figure out, well, what is the question asking for? And once I've done that, I can kind of figure out, well, what formula do I want to use? Question's asking for work. So I pull up my work formula. I know that's going to be the force times the distance. Then I look at my question and we start plugging numbers in. For the force, it tells me the object's got a weight of 500 newtons. Weight is a force. It's how much force you're pushing down on the ground with. That's 500 newtons. The distance that is carried is 4 meters. I plug those numbers in, 500 newtons times 4 meters, and voila, my answer is 2,000 joules. Next type of question might have to do with, looks like something like this. If I got a 40 kilogram dog and it's running at a rate of 6 meters per second, what is the kinetic energy of the dog? Well, how are we going to solve this one? Isaac, what do you think? I don't know for sure, but I'd like to find out. All right, well, let's do that. I've got a 40 kilogram dog running at 6 meters per second. The kinetic energy of that dog. Well, once again, let's figure out what the question is asking for. If I read the problem, it says the question is asking for the kinetic energy. So I go to my formulas, I find my formula that has kinetic energy in it. 1/2 the mass in kilograms times the velocity squared. Now I got to plug my numbers in. Put the numbers where they belong. I got 40 kilograms for a mass. I got 6 meters per second for my velocity. Now, in math, remember we have that order of operations. And so we have to do that exponent first. So I'm going to take that 6 meters per second. I'm going to square that first to get 36. 1/2 times the mass of 40 grams is 20 grams. And now I just got to multiply 20 times 36 together. And ta-da, 720 joules. One last type of problem. I got a 25 kilogram barbell that's stored on a shelf. Has 735 joules of gravitational potential energy. What height is the barbell at? We're assuming that the acceleration due to gravity is 9.8 meters per second squared. We're assuming that barbell is here on Earth somewhere. Now this question is set up a little bit differently. What is this problem asking for? That's a tough one, Mr. Call. Well, we'll give you a shot at here, Isaac. Let's see, 25 kilogram barbell stored at shelf has 735 joules of gravitational potential energy. Gravitational potential energy is equal to the mass times gravity times the height. All right. We know gravity is 9.8 meters per second. We look at the problem. It tells us the GPE, or the gravitational potential energy, is 735 joules. And it tells us the barbell has a mass of 25 kilograms. What we're looking for in this problem is the height. And so we have to do our math a little differently this time. This time, I have to set it up just as you see on the screen. Then in order to solve for my height, I'm going to have to take 735 joules and divide that by 25 kilograms and divide that by 9.8 meters per second squared. That way I get the height by itself. I have to do a little algebra. When I do that, take 735 divided by 25 divided by 9.8. I get a height of 3 meters. Max, got a question.
Anything else we need for the test?
Well, let's take a look. We also learned this unit about the conservation of energy and some energy resources. We learned about some different forms of energy. We had thermal energy, kind of the motion that particles have at the atomic level. We learned about mechanical energy, machines and objects as they move, that relationship between kinetic and potential energy. Chemical energy stored in the chemical bonds of things. We've learned about electromagnetic waves, electromagnetic energy. Electrical energy we're going to spend a lot more time with here in the next unit. And nuclear energy we should be pretty familiar with as well. And then we learned about the law of conservation of energy, and that energy just doesn't stay in one form, but it's going to change form. But in the process, the total amount remains consistent. We don't create or destroy the energy. And we also learned about a number of different types of resources of energy. And you, of course, have been working on a project on those. We were introduced to some terms called renewable and non-renewable. Materials that, resources that could be turned over and replenished in a short amount of time versus those that take a long time to replenish. Those fossil fuels, coal, oil, and natural gas. And of course, uranium or nuclear energy has a limited supply. And then we learned about renewable resources like solar and wind, geothermal, hydroelectric, hydrogen fuel cells, biomass, and so forth. And hopefully, in one of those non-renewable resources, you become kind of an expert on. All right, well, that should cover it. That's kind of a lot of stuff swimming around your heads, probably. I want to remind people that a good study tool is going to be going over your practice test and taking time to go through that multiple attempts and make sure that you do the best job possible. If you do have other questions, you can shoot me a note and I'll try to send answers your way. See what I can do to help. Other than that, good luck. Have a great weekend, and I hope everyone has a wonderful Easter on these most bizarre of times. Take care, and we look forward to seeing you soon.